Hello, everybody. Welcome to the continuing series, the Industrial Solutions Group training series on world-class sustainable manufacturing. Today, we want to talk about best value option analysis, the art of decision making, how to get decisions made properly and quickly in a plant. I'll be using the acronym BVOA, best value option analysis. I'm Mike Burchak, Managing Principal of the Industrial Solutions Group. I've got my contact information here. If you have questions as the webinar goes on, please type them in the chat bar. If you're listening live, if you aren't listening live, we will post this on our website. So just shoot us an email or give us a phone call. Just a brief synopsis of the Industrial Solutions Group. We are a group of companies, boutique engineering firms, if you will, that focus on getting industrial manufacturers in world-class performance condition. We have a variety of technologies that are listed. We have particular skills on front end, making sure that things are moving in the right direction, economic studies, strategic evaluations. You see BVOA, the best value option analysis, at the top of the list. That's what we're talking about today. Last month, we talked about sustainability and loss identification and elimination in particular. So an overview of today's webinar. The reason for doing a BVOA in the first place is manufacturing teams are constantly barraged with complex, difficult, expensive decisions. And as the world has become more and more competitive and manufacturing plants have limited resources, perhaps more limited than ever before, it has just never been important to do not just the right thing, or not just doing things right, but to do the right thing. And what I mean by that is that sometimes we go through life and it appears that we are just doing things properly. I remember years ago, my mother was looking at a magazine, How to Improve the Home, and she saw this great color scheme for a basement. Different shades of green, and put together the plan, and then mom and dad painted the basement, did everything right, prepared the surface right, got the good paint, they masked things off. It was really a well done technical job. They did things right. But what she had missed in the evaluation was that our basement didn't have a lot of natural light like the one in the magazine. Had she talked to somebody else, they probably would have pointed that out. But day after day and week after week, she went down and she felt that she was just among seaweed, and she learned to really hate this color scheme. And within a few months, they repainted, and it did look a lot better when they painted. So it's a case of really doing things right, the right reason, but it wasn't the right thing to do, and it had to be redone. I see this in manufacturing plants a lot, particularly as it relates to some expensive systems. You'll see it a lot with utility systems, and then you'll come in 5 years later, and the first thing that is on everybody's mind is, how much does it cost to move the fire water tank? How much does it cost to move the substation? Because these things are cheaper if you put them close to a plant, but if you put them at the wrong end of the plant, the wrong side of the plant, they can really get in the way of future expansion. And instead of becoming functional systems, they start becoming monuments. And monuments are very, very difficult to relocate, very expensive. So they can get in the way of a plant continuing to progress and keep up with the times and staying world class, even if they started that way. So we'll be covering a little bit about master planning, but mostly we want to get into this how do you get decisions made that are doing the right thing and sell them? How do you persuade management? And that requires using the language of management. So we'll be getting a little bit into finance, and we'll also talk about how equipment obsolescence, future projects, major maintenance that's upcoming can really help you. If you've got a good master plan, it can help you become world class. They don't have to be obstacles, they can be good things. So a little bit about decision making. We've made decisions all of our lives. When we were young, you had snacks. Somebody told you take one or the other. Well, the criteria is not that much. What tastes best to me? What tastes good? And I grab a handful and off I go. That was my decision making several years ago. As we get older, though, even selecting a meal at a restaurant seems to become a little bit more nuanced. There's a lot of good food on the menu. Obviously, people are making choices all the time to buy this food or it wouldn't be on the menu. But what goes through your mind as you're reading the menu? Well, it's not just what tastes good, but you're looking at calories and how hungry are you? And is it going to be so filling that I'm not going to be able to work later on today? Is it healthy for me? Do I have enough time to wait for the chef to prepare a meal that needs to be fully cooked? So our decisions become more mature as we become more mature, and they become more nuanced. Well, if we think we have trouble sometimes agonizing over a menu, think of the issues that you have making a decision for a small group, your own family, when it comes to changing homes, changing locations. Group decisions become more complicated. Totally. First, you want to go into something that everybody's happy with, that has an aesthetic appeal, but you want to know, does the layout work? And somebody else in your family is concerned, how far is it from school? How far is it from activities? How far is it from my personal work? Can I raise a family here? Are there other young children in the neighborhood? How about the cost of utilities and taxes? We haven't even gotten to how much does this cost. So monthly payments, obviously. If I got a car, where do I park it? Does it have a garage, et cetera, et cetera. So group decisions are complicated because it's not like reading a menu where you argue with yourself. Now you're discussing with multiple people, and you've got to try to come up with some kind of consensus point of view. Add another level of magnitude on decision making for manufacturing plants. We have many different departments in a typical manufacturing plant, and each of those departments have different folks. And in order to move ahead, if you've got the right people in these jobs, and most of the time that I see we do, we've got people that are smart, they want to move their business ahead, they want to move their department ahead, but they aren't working in a vacuum. So if I want to do something, it may have an impact on somebody else. In fact, you can almost bet it does. There was a movie a few years back, The Butterfly Effect. No matter what we do, it has an effect on somebody else. And these impacts on other people oftentimes are competing priorities. I may need more space for my equipment, for my people, for my meetings. So it's going to take space away from somebody else. Different people have different production demands. I will sometimes talk about high rent district, making areas and packaging areas. Whereas you have lower rent area, you can move offices, you can move utilities. We're dealing with costs, but they have the flexibility, at least technically, to work in some different locations. But if I'm moving people, that means they have to walk farther, they have to move further, and there's going to be discussion about that. What helps one party may not help another, so we're trying to provide consensus. Equipment, how do you look out into the future? Technology advances. Do you have room to put the next piece of equipment to automate? Or maybe it takes up less space. Maybe it would be smarter to do it now and offset some building costs. And then finally, with the budget, we've always got restrictive goals that we need to meet from the corporate folks because they've got commitments that they need to make in order to make sure that our products can be sold at reasonable prices. So that's where the master plan comes in that I see, and probably in the future sessions we'll talk more about master plan, maybe get somebody that really spends a lot of all their time on the master planning, talk about it. But the master plan, to me, frames the decision making. It's a process that helps all these groups to get together and look at their vision for the future, and they kind of package it up into a neat little bow. And when you go through that process, you realize there is a need for a lot of discussion, a lot of back and forth discussion, and if you do it right, you end up with a much better future plan than what you've got currently. And it really looks at things like, well, what are my production volumes now? What do we expect them to be in the future? How many SKU units do we have? What effect does that have on warehousing and storage, logistics? And if we're going to grow in this direction, where do we need to be putting some of our support office administrative areas, utility areas, on and on. Very good, deep discussions that become very important for world-class facilities. If you want to be world-class and stay world-class, then you really need to know what direction you're going in for the future. So when do you update a master plan? I see it happening in two ways. One is before embarking on a major project. Major is defined differently. Small plants, a major project for a small plant might not be a major project for a larger plant, but you tend to have your own idea of what major project is, and it really helps to get this common consensus of the management, the plant leadership team before you go about making a major change to your plant. Even if you don't have that major project, I think it really helps. Every 3 to 5 years, you'll see people refreshing their master plan because times change, their product mix changes, and it's time to revisit some of these decisions that really seem like the right direction 3 to 5 years ago. Maybe need to tweak the arrow a little bit. And it's that master planning process that gives plants a world-class edge, because there are a lot of things to think about if you want to be world-class. You have to think about how to maximize your capacity. It costs a lot of money to build the second plant or to expand someplace else, logistically, et cetera. It can become a very expensive endeavor for your company. Productivity, reliability, making sure we're effectively using capital, making sure our maintenance costs that were sustainable. All of these are very, very important aspects of the master plan. So switching gears just a little bit, if you have, and most plants do, a very solid plant leadership team, talented individuals that know what they're doing, they've got their eye for the future, they've been through this master planning process. Every year, people go through a budgeting process, and when you go through budgeting process, every member of that plant leadership team has ideas, ways to improve, and you start adding up all of these requests. And in this case here, I just made up some numbers, but total requests coming in to the plant manager to make a decision, nearly $8 million. But the plant manager here, well, last year you spent $4 million. We expect you to spend $4 million this year. So the budget way different than what the requests are. So how do you make those kind of decisions? And this is really a continual battle daily in plant organizations, setting priorities, figuring out what to do and how to go about it. We have a couple of options here. Plant manager has a couple of options. First option is to persuade corporate that the budget needs to be increased. The $4 million just isn't adequate. We've got a lot of good opportunities to advance the business, and we'd like more money. And good plant managers tend to be pretty persuasive plant managers. They speak for their plant, they stick up, and I've also been on the corporate side, and I've been on the receiving end of those requests, and you expect to have people pushing on you with ideas, and there is a lot of good, healthy give and take that happens, but chances are the 4 million is not going to turn into 8 million here. And but maybe there's a little bit of room. Maybe the plant manager can get to 4 to go to 5, or maybe if other plants in the system or some departments don't execute, maybe as the year goes on, there's a little bit more money or whatever. So there, what do you do with option 2? Well, I sometimes hear, well, it's better to beg forgiveness than ask for permission. And I will tell you that gets people in trouble, and I don't advise it. But I do love this quote from a business writer, Keith Davis, that when getting caught in the till about overspending a budget, his response was, well, we did not actually overspend our budget. The allocation simply fell short of our expenditure. And you can try that. I'm not sure if it worked very well for Keith. That may be why he ended up being a consultant and writing books. The option 3, and every organization ends up doing this continually. Management sometimes is defined as the art of decision making. You have to make decisions, where to make the final cuts, what are the higher priorities, and how do we move that. And that's where the topic for the day, we start getting into how do you deal with this, and how do you deal with it in a logical way that we don't typically learn at home in our personal lives, because the decisions aren't this complex. We also usually don't learn them in college either. You know, those of us, at least that were engineers, we were focusing on making technology work, not focusing on this decision making. So what I want to do is lay out a process that we found to be very successful in our business and in working with clients, and I'm hoping it'll be helpful to others. So I think of the process in terms of 3 gates of decision making. So if I were the plant manager in this situation where I've got very energetic, enthusiastic plant leadership team, they've got a lot of great ideas, but I just don't have enough money to say yes to everybody, I would start sending it through a screen. I'd say, okay, is this idea going to help make us world class? Because that's my goal. If I had a football team, if I were Bill Belichick, I'd want to get to the Super Bowl. Is this change going to help us get to the Super Bowl? Yes or no? If no, let's look for an idea that will help us. Maybe we need to make a better decision here. If it clears that gate, I'd go to the next gate. Is this initiative consistent with the master plan? We've spent all of this time and energy, we've pulled together the leadership team, and we have decided that this is the best way for us to be looking at growth and change and productivity improvements over the upcoming few years. This idea that I'm presented on its face seems to have some value, but has it been talked? Has it really gone through this screening of the master plan? Because I can see where if we do this, it's a change in the master plan that could upset the cart in some of these other business areas, and I don't really want to say yes to it until I really make sure we've got a consensus, and that consensus needs to be, let's revisit that master plan and make sure that we can make that change acceptable. So gate 2, use the master plan. It's not just a document that sits on the shelf, but it is a document that's very valuable in the decision-making process. But even going through those 2, you would typically find that we have more requests than what we can fund. So now we need to get into, does it make financial sense? And how do we figure out and compare the finances of a real broad range of different possible initiatives, everywhere from personnel to equipment to administrative to on the line process, very challenging, more challenging than would at first appear. If you clear those 3 gates and say, yep, let's put it on the list and let's execute it. So that's the question. What initiatives make the cut? And here you can just see a few ideas that I've thrown out. You get all kinds of different ideas that come in. Everybody's got a plan, and somehow you need to make this cut. And a lot of times that's cut. Most of the time, finances really play a big, important role. And we'll talk a little bit about why that is the case and why it should be the case. So most have probably heard the term net present value. I think it's a great tool, and we use it a lot in order to make manufacturing decisions. And I just wanted to put a little chart up to talk about the process and how this might work. So let's say you're the plant manager and your savings budget has been $1 million for this year. In other words, people can come to you making changes in a making system, on a process system, somewhere in the warehouse, a little bit of automation. You can spend up to $1 million in order to save money and reduce your ongoing costs. Well, here are the requests you get. Of course, it always gets more complicated. There are always more requests. There are always more twists and turns. But I just put 4 out here. You add up these requests, and on the surface, they all seem to be good ideas. They would all advance you towards your world-class manufacturing goal, and they're all consistent with a master plan. But the cost, $2.5 million, and you've got $1 million. So what do you do? Well, let's ask for some financial analysis. So you make sure the teams, hey, part of this you got to look at net present value. And what's interesting about this is one of the departments couldn't quite get it together. They're having trouble putting their capital together. Their project is just a little bit not as well developed as one of the other departments. So for me, that kind of makes that an easy decision. We'd say, okay, well, until we really have the project well defined and we've got our, know our net present value, let's just knock that one off the list. Doesn't mean it's a bad idea. Maybe it's an idea for next year. We thought we were hoping to get it together, and it didn't quite come together. So we can knock that off. But now I still have $1 million problem. My $2.5 million went down to $2 million a request. So what do I do? Well, I look at this list carefully, and it seems to me I could either do option 2 for $1 million, or I could do options 1 and 3 for $1 million. And I can't do them all. So those are my options. I either do option 2 or I do options 1 and 3. And now I look at the net present value, and I add the net present value for 1 and 3 and find out that it gives me a better net present value than does option 2 alone. So that's the answer. Let's do 1 and 3, and let's hold off on option 2. See if we can't find some other way to finance it. Maybe kick it down the line into next year, because it will return to over $2 million, $2,150,000 in today's dollars, versus only $1.7 million. It's a better financial investment. We'll do that. So we need to talk about time value of money and talk about days value to today's dollars. Just a couple of pretty obvious statements. For one, we know it's better to have $1 today than $1 tomorrow, and the reason for that is you can invest today's dollar, and if you make a smart investment, next year it's going to be worth a little bit more the second year, a little bit more the third year. So $1 today is worth more than $1 tomorrow. And that's what net present value gets into. And I've told family members, I've told people in the business, and I hear world-class manufacturers, they just hate to spend money. These ongoing expenses, year after year, inflation really makes it difficult to be competitive in today's world. But we love to invest money. And if you can get a good return on your money, and that's a way to really build your business for the build of the future. So, engineers make their careers built around that. And so just a little primer on investments. compound interest, a little bit of change in interest rates. This is why Wall Street's so interested in interest rates. You're making 3% on your money, 5% or 8%. Well, you take $1,000 today, and in 10 years, it makes a lot of difference on your interest rate. If you're at 15% interest rate, that's $4,000 in 10 years, and it's not even $1,500 at 3%. So if you're going to make an investment, why not spend time and try to make a smart investment? And it really pays off as you go down the line. By the way, a little, I don't know if people have heard of the rule of 72, but a rough way of, a very quick way, and it's a good approximation, is you take 72 and you divide it by the interest rate, and that'll tell you how many years it takes for you to double your money. So a real simple one, look at the 8% curve. 72 divided by 8 is 9, and sure enough, in year 9, we're crossing our $1,000 has become $2,000. So the rule of 72, real quick way without going into books and graphs and calculators. Albert Einstein even got interested in finance. He said, compound interest is the 8th wonder of the world. If you understand it, you earn it. If you don't understand it, you pay it. And if it was good enough for Einstein, it should be good enough for a lot of us. So what net present value does, what NPV does, is it restates cash flows in today's dollars. It's an easy way, as you saw in that previous example, on how do you make decisions, because we can bring everything in today's dollars. Not just, we'll start talking about a couple of points, but then we'll take it into cash flows, and you'll see how it works. And finance people will talk about this as discounting the value of future money, because we first will oftentimes calculate the cash that we get in year 2, the cash in year 3, the savings in year 4, et cetera, et cetera. But we need to try to bring that back to the present dollars, because we know that cash isn't as valuable in year 4 as it is today. So we bring everything back and we discount it into today's dollars. And we do that by using, switching around an easy formula. So we know that the future value of $1 is you take your interest rate, 1 plus the interest rate, and then to the number of years power, and then that's the future value. So if you had 3% interest rate, it would be present value at $1,000 times 1.03. If it's that first year, then it's 3% interest, and then another 1.03 squared would be the second year, and that would be the future value. But to find the present value, we just flip the formula around. Pretty easy concept for engineers and managers. So we're just flipping the formula around so we can bring everything back to the present value. So I in this equation is the interest, N is the number of years. So let's see how this works in a couple of examples. So assume we have a 5% discount rate. That means you'd expect your value of money to increase 5% every year, and you bought a piece of art for $1,000. Somebody wants to buy it in 3 years for $1,125. Was it a good investment? Well, we calculate it and we bring it back, and you'd say, okay, I've got $1,000 now. The net present value of this whole investment stream is I get $1,125 in 3 years. I divide it by 1.05, divided by 1.05, divided by 1.05, because it's 3 years out. That's $971. The verdict? Nope, could have done better. Because you said you could do 5%. That artwork really didn't turn out to be a very good investment. Had you invested the money someplace else, it would have been a better deal for you. Try example 2. 10%. I'm a really smart, astute investor. I believe that I can get 10%. So somebody says you got $100. You get $100. And they'll say, hey, we'll give you $150 in 4 years. Should you do it? Would that be a good investment? Well, you can do the calculation. Let's use shorthand, 1.1, that's 10%, 1.1 to the 4th power, and you multiply that, that's $102. Well, I have $100 now. This investment's $102. That makes my cut, right? That's a good idea. Let's do that. And turns out that computers make this really easy calculation. You can go out to Excel. There's an NPV formula, so it's real easy to calculate these. You just need to get the strings of cash flows. That's the difficult part, and then the computer will do the rest for you. So let's look at how it works with a string of investments, because this is kind of our typical thing, right? We've got an upfront investment. Maybe we buy some piece of equipment, variable speed drive, $50,000 or something, some piece of automation. And then there's a series of cash flows over a period of time. So let's say that our target cash flow discount rate in our company is 8%. And you've got a piece of equipment you'd like to replace. There's a better way of doing it, but it's only going to be around for 5 years for whatever reasons. And it has no value after 5 years. So do you recommend the investment? Well, now you can't really tell by looking at it whether this is going to meet the cash flow. But with NPV, it's pretty straightforward. Just put together a little spreadsheet, and we can look at the cash flow each year. In year one, we spent, that's a negative number, $50,000. And because we spent it this year, it is real money, $50,000 real money. Well, in year one, if you look at the graph, it's $10,000 to the positive, but we have to divide that by 1.08 because that's our discount rate. We need to bring it back into year one. So the 10,000 becomes 9,259. In year two, we were up to 20,000. But the net present value of that, because we have to divide by 1.08 squared, is 17,147. We do that for every one of those 5 years that this piece of equipment's going to be in service. And when we do that, it totals up to $42,689. So should we do it? Pretty clear. No, we don't do that because we've got 50,000 now. Why would we put money into this investment and end up with $42,689? It makes no sense. Bad investment. Those of you that are real good at math, if I would have changed this a little bit, what if I would have given this a 6-year life or a 7-year life? Well, you can see that the net present value is going up, $18,000, $20,000 with every year. And that declines with time but boy, had it lasted 6 years, maybe you conclude a little bit different. So the assumptions that are going into this become very, very critical. Kind of a trick question, a little bit like who's buried in Grant's tomb. And sometimes cash flows vary. Piece of equipment, yeah, we like this piece of equipment, but boy, we got to spend some major rebuild money in year 5 and year 9 or something. So we might even go negative some years, got ups and downs. You can kind of tell by this cash flow that this is probably not the greatest investment in the world if this is really what you're doing. But how do you deal with that? Same answer, net present value. You just got to be careful to make sure you're using positive and negative numbers properly. If it's below the line, if it's negative, it's out, it's one direction, and cash it's coming into you is positive. And if you keep your positives and negatives straight, then you're okay. A couple of real world examples, or a little more of a real world example. I was thinking about buying a sports car. I really liked it, but it was kind of a pricey car, but it really looked sharp, as you can see in the picture. So you do a net present value of your sports car, and you say, yeah, I'll keep it about 7 years and then probably sell it. And it'll probably be worth about $30,000, maybe 40% of its purchase price after that time. So you can lay out all these cash flows in a nice little table, right? So, the initial purchase minus $75,000. Cars, though, are just drained money. There's no cash coming in on these. I got a fuel bill each year. I got maintenance and insurance. So I've got operating expenses that are going on years 1 through 7. But at the end of the time, at year 8, I get $30,000 of it back because I sell the car. And I've made a simplifying assumption here. I say, well, I'm going to pay cash, which Be nice to pay cash, but how many people do that? But you could look at cash versus financing and see how you do there too. It's an expensive buy, $91,693 in current dollars. So I'm not really spending $75,000 on that car today. I'm really spending $91,693 because that's what my discount, that's what the value is worth to me of that time value of money. So I'm getting pushed to buy a hybrid, a little bit more practical car. You know, it can carry some more people. It's not just a two-seater. A lot cheaper, $30,000. And again, 7 years. I can keep basically these assumptions the same, but it gets better fuel mileage, and I get $12,000 back at the end of the time for residual price whenever I resell it. So I do the net present value on that, and same calculation, just different numbers. $42,000 out of pocket. So instead of spending $91,000, I spend $42,000. That's a $50,000 difference. But I really like that sports car. So should I try to find a way to make the $50,000 work? Because we all know there's more to life than money. And that's what we're showing here. This gets us into our best value option analysis template, our BVOA template, where if you notice, we can give a little description of the options that we're looking at. We can put the options in here, definition of the options, and put some pros and cons in, and talk about what I'd call the intangibles. You know, safety, hard to put dollars on those. You can work hard and sometimes get it, but it's hard. You know, what's the cost of an injury, that sort of thing. So if it's an unsafe, you know, one project's more safe than another, then that's important. Scheduling, does it timing work on projects? You know, again, some things are hard to quantify in dollars, others aren't. Where you can quantify them, you do that. Where you can't, then we can put them in the intangibles column, and then we can just for documentation talk about the key assumptions. So when we come back 6 months, a year from now, we know what went into this decision, and do a recommendation with rationale. Nice little cover sheet. Let's do this on our car. So we said, okay, we're trying to decide between the sports car and the hybrid, and we really like the sports car because it looks great and it's fun to drive, but it's expensive and it's really not practical for my growing family. But the hybrid, it's practical, you know, and it's energy efficient. I don't like the aesthetics that much, and it's really not fun to drive. And then over in the intangibles, we can start giving it scores and say, well, safety, I don't know, I'm going to drive the sports car faster. I'm more likely to get in a wreck, so score that lower. This is a 1 to 5 scale, 5 being the best. Does it feel good to drive? Is it aesthetic? Yep, you bet. That score is high, and I really don't care much for this hybrid. How about operation and maintenance? You know, actually, the sports car's old technology could get under the hood, and I can do some work on that, but the hybrid, you know, I don't know how the hybrids work, so I'd have to train myself or just hire somebody to do it. So the hybrid's lower there. Is it practical? Boy, the hybrid really wins on that one. Is it comfortable? Yeah, wins on that one. That getting 3 people in my sports car wouldn't be very comfortable when we do the sports on the weekends. So we do that, and notice we got a weighting score. So we've ended up with the intangibles scoring better, 3.8, 3.4. It's still not perfect. Maybe there's a better car out there for me, but I'm starting. You can see what's happening here. I'm starting to talk myself out of the sports car. You know, my wife was probably right. You know, it's a sports car would be nice, but it's really not very practical. And by golly, that's what the BVOA is showing. And I had some basic assumptions and pretty clear direction. I've talked myself out of it with a BVOA. Let's bring it into the manufacturing world. Let's just look at upgrading an air compressor system. We have a 3 compressor system, and We have a 3-compressor system. One's permanently installed. It's nice. You can see by the room there's some space to put another one in here. But you know, the plant has grown, and we started getting these rental units in, and something we like to do on systems like this is develop a load duration curve, so you can see with percent of time of the total year. This actually shows you, you know, what percent of the time you're operating up in this zone and the others. It's kind of a neat thing, because what you can do then is you can start staging air compressors, and this is what they do. They pretty much base load that 2500 CFM compressor because it's cheaper to operate than rentals that are using diesel. And we bring the rental unit 1 on. But those 2 units alone are only able to satisfy the plant for you know, that percent of the year, about half of the time, and so the other units running at least half the time as well. So it's quite a bit of you know, we do need the 3 rental units. And somebody has this bright idea. Well, let's quit spending money on these rentals. So we have a couple of options. One is we can do nothing. We could stick with the current plan and just, you know, have 3 air compressors, right? Permanently installed 2 rentals. Or it could replace those 2 rentals with a 2500 CFM compressor. Now, I know we have people on the webinar that are international in the metric system, so I gave you a little conversion. 1 CFM, 1.7 is equal to 1.7 cubic meters per hour, so that'll allow you to kind of translate, you know, so 2500 CFM, it's like 4,000 cubic meter per hour unit. Okay, so we do a BVOA. We've got 2 options. They're pretty straightforward. Let's do a BVOA. So we talk about this plant air compressor. We have 3 air compressors, 2500 CFM, 2 1250s. These are unlubricated screw machines. Each rental unit costs about $22,000 per month to operate. Rent's expensive, and fuel costs on top of that. Diesel's expensive. That becomes a pretty expensive one. So is this BVOA? So this BVOA is evaluating those 2 options. It's pretty nice and clean. So we go through. We summarize the options here. We talk a little bit about pros and cons. It's kind of nice having permanently installed equipment. And but we also know there's probably some better equipment out here than these unlubricated screws. So maybe there's something else that we could look at down the line. But we just wanted to slam this thing through quickly and get a decision made. Let's get rid of the rentals. Safety. Nothing unsafe about either one of these systems. They score well. Schedule now. Takes a while to get a new compressor and dryer designed and engineered and installed, purchased and installed. So that we take a ding there. Maintenance. Well, if we get a unit like the one we got, we've already got people trained. We know how to maintain it. So that's an edge. We're sticking with the same capacity. It doesn't really help us on future capacity. We do like the reliability. We think that works a little bit better. We've got 2 machines that fail instead of 3, and you have more likely chance of a failure when you have 3 machines. So we gave that a little bit of an edge. But look, you do the analysis and you do that net present cost. I switched it around to get rid of the negative numbers. So this isn't value, positive. This is the cost. What's going to cost me? It's like my car. What's going to cost me over these upcoming years? And boy, it's over $6 million if I stick with what I'm doing. About $4 million if I take the new option. So we say, yeah, let's replace the rental units. There's a lot of money to be had there. But then something strange happens. This happens to me on times. I bet it's happened to others that are listening. We did this great job of evaluating these 2 options. And I don't know, options seem to be like seeds planted on fertile ground, right? When you start this brainstorming process, other people have ideas. Well, you know, Mike, why 2 units. How about 2 half-size units, just like the rentals, so we could do that. And you're thinking, yeah, you could do that. You could do that. It's going to be cheaper. It's going to be, well, it's going to be more expensive. It's always more expensive to buy 2 half-size things than 1 full-size thing. It's a rule of the 0.6 rule. But maybe I could see that. At least if it goes down, it's not as reliable. But if it goes down, then you're only losing 25% of your plant production unless the big one goes down. So maybe there's a reliability play there. Should we replace all the compressors with a large variable speed compressor? Well, maybe, because variable speed is 30% more efficient than, okay, so there's some reason to believe that our energy costs would go down. How about both of these 2 new compressors with a variable speed drive compressor? Okay, possibly. Maybe we should add some extra capacity for additional future loads. How much would it cost to spend? Okay, so that's a variation. And then now, with sustainability, how about reclaiming the heat off these? 90% of the energy that goes into an air compressor gets thrown away at the air compressor as heat. So there's a lot of energy that could be reclaimed. We could heat boiler water. We could heat the building in the winter. And you could let your mind go. There might be a lot of variations, a lot of different options. The process is the same. You could add them to the list, do an honest economic evaluation and tangibles and intangibles, and make a decision. But it can also stretch out the process a lot. So we really like being clear up front to define the stakeholders. You define the stakeholders, and there are a lot of them, because when you're making a lot of your project changes, usually, as we talked earlier, these project changes or initiatives don't just affect one person. They don't affect one department. They can affect multiple departments. Maintenance people, operating people, engineers, all have points of view. And we've heard the expression, 2 heads are better than one. Well, in the plant, you've kind of got a whole community trying to make the decision. But people's point of views do count, and they can add value. So it helps to consciously listen. But somehow you need to bring so there's a divergent period of a BVOA, but you also want to, your goal is to try to get a decision made. So we need to make it fast, and there's a little bit of an art to doing that. Understanding the stakeholders up front can really help the decision-making process, really help you make decisions more quickly, and they're better quality decisions because you're getting more options on the table. So we talked about the BVOA, why it's there, how finances play, how the language of management becomes finance, and how they use it to make decisions. Let's talk a little bit about the steps for putting together a BVOA. So the first one, remember the picture we had the engineer. Why don't we get rid of these rental units? It starts with an idea. Somebody has seen a problem, something that's unsafe, quality problem, reliability issue, something's too expensive to operate, too expensive to maintain. You can't hardly look at anything in this world that there isn't a better technology or a better approach. Everything can be improved. It's kind of the engineering logos, right? That's why a lot of us have become engineers, is because we know that the world continually changes and can continually be improved. But it starts with that improvement opportunity. And then it's, okay, who would be affected by this? So it really helps to identify those stakeholders. If you need a couple of key people in your team, maybe you aren't very good at estimating capital, maybe you aren't very good at estimating the cost to run different pieces of equipment, maybe you don't know much about safety or environmental. Depending on your project, you probably will need to reach out to some other folks in your company. It could be Could even be a maintenance company that you hire, to take care of equipment. They really understand the piece of equipment or system well and can help you evaluate. Whatever it takes to try to get the right knowledge base and the right skill level as part of your team. Then the fourth step is kind of a fun step, brainstorm. What kind of options can we come up with? Like the compressor, we ended up with 7 or 8. Well, probably would have been nice to know some of those earlier, because you do 2, and then if you do 2 more and 2 more, what could be a 3 or 4 week process ends up becoming a 3 or 4 month process, and it's all because of decision making, not necessarily that there's that much work on each option, but it's people just need all of that in order to make the decision. They need to see the big picture. They may need to make sure there's a thoroughness. They need to make sure that ideas have been properly evaluated. And that evaluation process, you build credibility for your team and for yourself personally as you evaluate, and people have faith in the numbers and faith in the evaluation. And some folks are kind of hesitant. They would start with the BVOA and not put in that last space where you talk about the recommendation. But I think it's always important for the person that's leading this kind of an analysis to be willing to summarize and say, hey, based on everything we've seen, this is the way I believe we should go. And many times management will agree with that. Sometimes they don't. But I find usually if you've been diligent, when they don't, it's usually one of the other options they prefer. And a lot of times that's because they know something about the future that you didn't know. You missed something like, hey, I got this future project coming along, so I really want to do the 10% more, and that will help offset buying another air compressor in the future. So you hear that and you kind of flush those ideas out. And then, of course, 7 is implement it. And if you've got a good idea of the project, and then again, I think most folks are more familiar with the implementation process. Now it's time to, get funding, put together that design engineering team, and then go off and implement it. So it's a pretty straightforward process, and the more thorough you are identifying things up front, the quicker it goes. I have a couple of tips as you go through the process that I found to be very helpful. One is, don't forget the low capital option. In the case of the air compressors, low capital is keep doing what you're doing. 0 capital. Just keep renting equipment. We've been doing it for the last 6 months, last year. Why don't we just keep doing that into the future? If you don't put it in, somebody's going to be sure to ask for it, because why spend money if you don't have to? And you can bet that somebody, if they had control of my budget on my sports car hybrid, why don't you just stick with what you've got? Your current car is okay, and you need to be prepared to answer that question. So you can't avoid that question. The second thing is to remember that if the goal, and I think it should be everybody's goal, is to be world class, because you want a bright future for your plant, for your company, for your workers, for yourself. But world-class plants are not built around yesterday's technology. That doesn't mean you automatically take out yesterday's technology. But if you have a situation where you're looking like a piece of equipment breaks down, then a lot of times the low-cost option is just replace it in kind. Well, the low-cost option is usually fix it one more time. But then it could be replace it in kind, because it fits. All the connection points are the same, so it's easier to do. We don't need to do an engineering. But I had a great mentor when I was first starting out in engineering. And I came to Ed and I bragged to him about how I had come up with a better way of doing it than these more experienced engineers had 10 years ago. And his response was the kick that I really needed. And he said, well, you'd be one heck of an engineer if all you did was repeat what somebody did 10 years ago when we have all this new technology, wouldn't it? I mean, it's your job, ways of doing things. So it's an important lesson that I was fortunate to learn early in my life, that yes, it is our job as engineers and managers to find ways to move things ahead, and you got to constantly keep moving ahead, or you don't move, and you aren't going to be world class. And the third thing is, I'd say really think about the big picture when you're looking at financing. You know, a lot of people look at equipment obsolescence. You know, 2 years, I've got this major rebuild going on maintenance-wise. I got a future capital project. How do I deal with that? But if you're trying to improve your department, these kind of major systemic changes, these step changes that make a difference, can really help you move ahead, because they could get plugged into the BVOA. You know, like the air compressors we were talking about. You have to do a major rebuild. That's half the price of a new compressor. So now you plug that in 2 or 3 years out because it's coming due. It can help you maybe justify an even a more exotic option. You know, maybe we should replace both of these compressors with variable speed drives, or heat recovery compressors. Maybe that really is the best life cycle cost analysis, the best present value that we can get for our plant. So in summary, it is absolutely important to do things right. It's important to do things legally, specifications, codes, regulations. We need to make sure that we do things right in our manufacturing facilities. But I think in order to be world class, it's even more important to make sure you're doing the right thing, because you can get yourself locked in and your plant can really start getting dated, obsolete with time. And if you're looking for tools to make sure you're doing the right thing, Master Plan, BVOA are the best tools that I've seen to really help make sure plant teams have getting all of those best thinking together, and then making sure that each of the individual pieces that go into that puzzle are really adding value. And that way you make sure that you've got the best ideas on the table, the smartest ideas on the table, and you've tried to do it in a way that gets decision making done broadly and quickly among all the key individuals. So that's an absolutely winning combination whenever you can do that. So that brings me to the end of today's webinar, and just wanted to provide a few other pieces of information. If you'd like, send us an email to you can ask for a BVOA template. We'll send you an Excel spreadsheet, so that kind of helps you get started. It's got some of the formulas in it. And for those that interested in a professional development hour certificate, also email that request in, and we'll get this out to you in the email. And in March, I'm planning on some travel. So won't be available for a presentation, but we've scheduled one for Tuesday, April 16th. Watch for the invite, and I think what we're going to talk about is smart controls and artificial intelligence. So that's an interesting conversation, and I hope you join us for it. Thank you very much for participating. I will leave this slide on the screen for a while. You can go to this link. We'll upload in a, by the end of the day, we'll upload this presentation, so it will be available. If you know of others that haven't, that would like to see the presentation and haven't done it, we'll upload it onto the website. Also, feel free to give me call, email if you have any questions regarding the webinar or other things in your plant. I'll do what we can to help lead you in the right direction. So thanks very much, and have a nice day.